Okay, we continue with Section 4. Section 4 is GPU computing systems with Nvidia SXM or AMD OEM modules. Things are always move forward. After Nvidia has invented this kind of GPU computing with the GPUs in the form factor of PCIe adapters. Later on, Nvidia published their GPU computing system with the so-called SXM module. At the beginning, it's with the A100 GPU, and later on with the Hopper 100 GPU. And here you can see that an SM module from Nvidia is a motherboard with the GPUs, and the GPUs are interconnected each other by using the Nvidia NVlinks. And we take the example here is this module with 8 H100 GPUs. They are fully connected each other by NVlink. If you look at this system architecture, you can see that this is the so-called SXM module. And this is a motherboard with 8 GPUs. 8 GPUs are interconnected each other by the NVlink switch. And the NVlink switch forms a kind of fat tree, something like a fat tree, to connect the GPUs to each other. This is the module. This is the so-called SM module. To compare this XM module with the old system with only PCIe adapters, I put the old system with GPUs in the form factor of PCIe adapters here under. We can see that the GPUs in the old system with GPUs in the form factor of PCIe adapters, the PCIe adapters are connected to the PCIe switch and then connected to the same root complex here. Root complex is RC, or it can be connected to a different root complex. I mean, the second PCIe switch could be connected to another root complex. That's going to be if we don't have this link, if we have another root complex, another PCIe switch connected to this root complex, there's also this kind of system. That's another common architecture of the GPU computing system with GPUs in the form factor of adapters. Very clearly, the difference is that with this new system architecture, what you have is not only 8 GPUs, but the 8 GPUs are interconnected each other by the NVlink switch, and the cables. Now, this is the 8 GPU module, and then you have the NVlink switch. At the same time, Nvidia also introduced to the marketplace another module with only 4 GPUs. If that's with 4 GPUs, then you do need to have the NVlink switch. The 4 GPUs are going to be interconnected each other by the NVlink. So no switch, but just links, because you have only 4 GPUs. Anyway, this is the SXM module from Nvidia. You have GPUs interconnected at the same time by using the NVlink. Okay. And we also have this kind of solutions, these kind of systems from AMD. At the beginning, the solution comes from AMD is the MI250. Okay, be careful here. We won't discuss MI250X. So MI250X is not included in this section discussion, because MI200X, you have just 1 letter more than MI250, but its architecture is quite different. we are going to touch on MI250X in Section 5. In Section 5, we are going to discuss MI250X. So here we only look at MI250. This is the reference architecture published by AMD. If you have 8 GPUs, the 8 GPUs are interconnected each other by XGMI link. In fact, XGMI link is the Infinity Fabric from AMD. So the 8 GPUs are interconnected each other. They don't have the same kind of switch like the NVlink switch. They don't have the NVlink switch, but they are using these kind of links to connect the GPUs together. And then these GPUs are going to be connected to the system by going through the PCIe links. Here you have an optional PCIe switch, or you can connect directly to the CPUs without using the PCIe switch. But we can see that most of the systems they are using this kind of PCIe switch. Now, this is the reference architecture for 8 GPUs. Now, it's not the picture is not so big to read, but here, don't worry, we have also the same time from AMD the OM module with only 4 GPUs, 4 MI250 GPUs. Okay, so this is the system architecture I pulled from the Gigabyte website. This is one of their servers supporting the 4 MI250 GPUs. So the 4 GPUs are interconnected each other by using the Infinity link. You can think they are this kind of infinity fabric links between the GPUs. Okay, and then the GPUs are connected to the CPU by going through the PCIe switch. And this PCIe switch, at the same time, it has been reserved 2 slots for the NICs, for the network interface cards, for this kind of connection to the network. We are going to discuss this one later on, but for now, we focus on the interconnection between the GPUs and their connection to the system. That means to the CPU. To the CPU is PCIe links, and between the GPUs. For Nvidia is NVlink. For AMD, that's their Infinity Fabric links. Okay, now things moved to MI300X. For MI300X, this is the reference architecture. You have 8 AMD Instinct MI300X GPUs. Okay, this time the 8 GPUs are interconnected each other by a kind of auto interconnection. And the red line here is the auto interconnection, and the link here is the Infinity Fabric. And 8 GPUs are interconnected each other. And then the 8 GPUs are going to be connected to the CPUs using the PCIe links. So it could be go through the PCIe switch. It could be directly to the CPUs, but there's PCIe links. Now, we have a look of the real system available from the marketplace from Gigabyte. You can understand this is the OEM module, and this module goes here. And this one, this black square, is the OEM module. You have 8 GPUs. The 8 GPUs are interconnected each other by auto links. Okay, auto links. Now it has been not shown here, but really you have this kind of auto links between the 8 GPUs. And then the 8 GPUs are going to be connected to the CPUs. That means they are going to be connected to the system by PCIe links. Here we have the PCIe 5.0. And usually the design from the marketplace, we can see is that usually the connection from the GPU to the CPU is going through a PCIe switch. At the same time, it's always reserved some slots for the NIC, for the interface for the network. Okay, so here we have two slots reserved for the first two GPUs, and then we have another two slots reserved for the second two GPUs. Now we are going to talk about this kind of network interface adapters reserved for pretty much for InfiniBand. We are going to discuss later on, but right now we focus on the GPUs, their interconnection between GPUs, and the connection from the GPU to the system. Okay, if we come back to the architecture, we have gone through the architecture. We are going to understand that the architecture of AMD OEM module and the architecture of the Nvidia SXM module, that's pretty much very similar. Okay, so you have multiple GPUs, like I've shown here. You have multiple GPUs connected to the system, means to connect to the CPUs by PCIe. Here, you have multiple GPUs connected by PCIe to the system, and then you have a kind of interconnection between the GPUs. I'm going to use NVlink as the example. This discussion also holds true for the AMD OEM modules, except that for AMD OEM modules, the link you are going to use is Infinity Fabric, not NVlink. But that's the same idea. The interconnection topology could be different. For NVIDIA, the interconnection is much more like a FAT3. For AMD systems, we know for AMD OEM modules, for MI300, they have moved to this kind of auto interconnections. So anyway, there can be interconnection between the GPU systems. So that's I have shown here. This is the interconnection between the GPUs. Now, usually we know that from the marketplace, we know the quantity of GPUs connected to a node is 4 GPUs per node or 8 GPUs per node. And then these GPUs are going to be interconnect each other. So if you look at this new interconnection between the GPUs, okay, what's going to happen? What's the effect for the programming? What's the benefit for the programmers? Okay, now this is still the I copied the MPI plus peer-to-peer memory access programming model that has been used for the GPU computing system with PCIe adapters here. And I just added this kind of interconnection between the GPUs. Then what's the benefits for the programmers? Okay, the benefits is here. You know, for the GPU computing systems with PCIe adapters, the peer-to-peer memory access between the GPUs goes through the PCIe link. So this is the way how it goes through the PCIe link. This GPU can access the memory of another GPU, but you have to go through this PCIe links. Okay. If we have this kind of interconnection network between the GPUs, that means we don't need to go through the PCIe anymore. So we don't need to go through the PCIe anymore, the peer-to-peer memory access. I mean, you don't need to go through these PCIe links because it's slow. It's slow. And because NVlink is much more faster than the PCIe, right now, the fact is that what you can do is that the peer-to-peer memory access now can go through the NVlink for NVIDIA. The peer-to-peer memory access can go through the AMD Infinity Fabric interconnection between the GPUs for AMD. So the same thing. But for NVIDIA is NVLink, for AMD is Infinity Fabric. But the peer-to-peer access, they don't need to go through this PCIe anymore. So no more. That means what? That means the peer-to-peer memory access will be much more faster. So if you have programmed, if you have written your program to run on the GPU computing systems with PCIe adapters to do the computing, and then suddenly you have been given these kind of new systems. And there is the new interconnection between the GPUs. Your code, your program, it doesn't need to be modified. It can be moved directly to this new system, and it is going to work. And because right now you have this kind of new interconnection between the GPUs, and it is fast, your program is going to benefit from the bandwidth available from this kind of fast interconnections, and your program will be running more faster. You as a programmer, you don't need to do anything. You just migrate your application from the GPU computing systems with GPUs in the form factor of adapters, of PCIe adapters, to the GPU computing systems with the Nvidia SXM or AMD OEM modules. Your program is going to benefit from the increased bandwidth between the GPUs by going through the NVlink or the AMD Infinity Fabric link instead of going through the PCIe. So that's the direct consequence of this kind of architectural evolution. Okay. I want to show you really we have the performance improvement. What I'm going to do is that I have the chance to access a system, which is a system with AMD GPUs. That's AMD MI250 GPUs. This is the architecture of a node. Basically, you have infinity links, infinity fabric links between the 4 GPUs connected to the system. And the system, you have only one CPU. The GPUs are connected to the system by using PCIe links. This is the PCIe links. So the GPUs are connected to the PCIe links. If we look at this PCIe link, the PCIe link here, the single direction bandwidth is 32 gigabits per second, okay? And the fabric, the infinity fabric between two GPUs, the bandwidth is 50 gigabits per second. This is the early generation of products from AMD. So this is the bandwidth of the system for the GPUs. Okay, what I'm going to show you, this is the output of a benchmark to test the bandwidth between the GPU and the CPU. Between the GPU and the CPU goes through these PCIe links. So we are going to measure this bandwidth. And also we are going to measure the bandwidth between two GPUs. Okay. We know the bandwidth for between the CPU and the GPU is 30 gigabits per second. That's going through the PCIe link. And we know the bandwidth between two GPUs by going through the Infinity Fabric is 50 gigabits per second. Let's have a look what's the measured results. Okay, the MI250S, it has 64 gigabits per, it is 64 gigabits of memory. That's the total memory. So what to do the test, what we are going to do is that the system has been partitioned into two NUMA nodes. Now, in section 1, we have discussed the fact that the AMD GPUs can be partitioned into NUMA domains. That's also called NUMA nodes. So here, the system has been divided into two parts, NUMA node 0 and NUMA node 1. NUMA node 0, let's see this NUMA node 0. This NUMA 0 is connected to these two GPUs. GPU, let's see, this is GPU 0, this is GPU 1. So this is the NUMA node. We are going to run the test. So the first, this column, the left-hand side column, we are going to measure the bandwidth between the CPU and the GPU going through the PCIe link. So we are going to have 64 gigabyte of data, which fills into the GPU memory. The GPU memory maximum is 64 gigabytes. So you fill in all the memory, and then you copy the data from the CPU to the GPU and from the GPU to the CPU. You are going to do it multiple times. At the beginning, because the cache effect, you won't have very high results. Here you have 8 gigabytes per second, and here you have 9 gigabytes per second, the first run. And the second run, you are going to see that this is from host to device. And this, the second run, the second part is going to be back from device to host, from GPU to CPU. And from GPU to CPU, we are going to read, this is 20 gigabytes per second. And here, this is 13 gigabytes per second. And then we are going to repeat this benchmark. The third time, we are going to do host to device again, and we are going to reach 14 gigabytes per second and 13 gigabytes per second. That's from the host to the two GPUs. Okay, and then we are going to measure again from the two GPUs back to the CPU. Okay, from the two GPUs back to CPU, we are going to reach 20 gigabytes per second and 40 gigabytes per second. To the GPUs, we are going to have 40 gigabytes per second and 13 gigabytes per second. Okay, and here is 2013. So we can safely say that the bandwidth between the CPU and the GPU is something around 13 to 14 gigabytes per second. Okay, 13 to 14 gigabytes per second. You measured multiple times, and you take the bandwidth. You don't take the number at the very beginning because the cache effect, and pretty much you need to forget about the maximum numbers. So I can safely say the bandwidth is around 13 to 14 gigabytes per second from the CPU to each one of the two GPUs. Okay, that's what we measured, and then what we are going to measure the bandwidth between GPUs, because each NUMA node, you have only two GPUs. So GPU 0 and GPU 1, you copy the data from GPU 0 to GPU 1 and then back from GPU 1 to GPU 0. That's the bandwidth you are going to have. And the data, because this measurement has been done after the first the column, the left-hand side column has been done, so the data are already in the memory. So we can rely on the first or the second benchmark results. There is no, it seems there is no big difference. What we can see is that between the two GPUs, from GPU 0 to GPU 1 and GPU 1 to 0, what you have is 30 gigabytes per second, and this one is 24.5 gigabytes per second. And then the video has been cut. Let me start from where it has been cut. What I'm saying here is that the column, the left-hand side column has been tested. The data are already in the memory. Now we can measure the memory bandwidth. Now we can measure the bandwidth between two GPUs by going through the Infinity Fabric. So in each NUMA node, we have two GPUs, the GPU 0 and GPU 1. We are going to measure the bandwidth from GPU 0 to GPU 1, and then from GPU 1 to GPU 0. What we can see here is that the first bandwidth we have is 30 gigabytes per second. And then the second one is 24.5 gigabytes per second. And here 25.8 gigabytes per second, and then 25.3 gigabytes per second. That's the memory performance. We know for the bandwidth between the CPU and the GPU by going through the PCIe link is 13 to 14 gigabytes per second. And then for the peer-to-peer memory access between two GPUs, we have around 24 to 25 gigabytes per second. This is peer-to-peer, and this is going PCIe, peer-to-peer, going through the Infinity Fabric. Okay. Now, clearly we can see the bandwidth by going through the Infinity Fabric. The bandwidth doubles the bandwidth of the PCIe. So that means that means here, if you have an application which is using peer-to-peer memory access, because there's a kind of a programming model for the GPU computing systems with GPUs in the form factor of PCIe adapters. For these kind of systems, there is a good chance that the programmer has to use peer-to-peer to have the GPUs communicate each other. If you have this kind of application, for any applications that has been written using MPI plus peer-to-peer memory access for GPU computing systems with PCIe adapters. Now, with this new system architectural evolution, what I mean is that with the addition of this Nvidia NVlink network, if you migrate your application, your program from the GPU computing systems with PCIe adapters to GPU computing systems with SXM or OM modules, you don't need to do anything. You do nothing. By the increase of the bandwidth of the peer-to-peer memory access, your application is going to run fast. The execution time of your application will be shorter than before. So this is the architectural benefit we get from this kind of addition of the NVlink network or AMD Infinity Fabric Link without doing anything specific from the programmer's point of view. From the programmer side. So this has been shown by these kind of measurements. You have this peer-to-peer memory access, the bandwidth doubled. So if you have this kind of you are using this kind of programming model on the system by moving to this system with NVlink SXM or AMD OEM modules. Your program will be running faster. Okay, so this is the first benefit we got with this kind of GPU computing systems with SXM modules or AMD OEM modules. We are going to have a rest of 5 minutes, and then we are going to continue to have a look of the other advancements of the of this kind of systems with this SXM or LM modules. Okay, let's have a 5-minute rest, and then we continue afterwards. I'm going to stop the recording right now. Thank you.